Hi, welcome to AB Video 2.1a, the limit definition of the derivative. I know we're halfway through Chapter 2 at this point, and we've been talking about derivatives, but we're now going back to the actual limit definition of the derivative. And the first thing I want to talk about is to show you a visual of what's going on. And here we go. Okay, so what we have is a curve. We have a point P on that curve, which is the point x comma f of x. I'm going to show you the tangent line to the curve at that point. Now what we're going to do is we're going to create a second point Q, which is h away. Now I don't know why this little guy is in the wrong place, so I'm simply going to delete him. But this distance here is h. Therefore, if this is x, then and this distance between them is h, then this is the point x. This is the x coordinate x plus h. So we're going to create point Q, and the coordinates of point Q are going to be x plus h comma f of x plus h, since this is the graph of f. Okay, now I can draw a line between P and Q, and that line will have a slope, of course, of y2 minus y1 over x2 minus x1, which is f of x plus h minus f of x over h plus x plus h minus x, which of course is just h. But what I'm going to do is I'm going to keep point P stationary. I'm going to let point Q approach point P. So we're going to let, in other words, we're going to let the distance, the x value distance between the 2 points go to 0. And as you can see, when we get there, when point Q is actually on point P, it is now not the secant line, but now it is the tangent line. So what we have is that the derivative, which you know is the slope of the tangent line, in effect is the limit as h goes to 0 of the slope of the secant line. So if we look at that secant line, remember it's f of x plus h minus f of x over x plus h minus x, which is just h. Okay, so what we have now is our definition, 2.1, the derivative in the tangent line. So as we said, the slope of the secant line is f of x plus h minus f of x over x plus h minus x, which in effect is f of x plus h minus f of x over h. If we let Q, sorry, this is going down. If we let Q approach point P, i.e. if we let h go to 0, then we get the tangent line, and that tangent line has a slope, which is called the derivative, of the limit as h goes to 0 of f of x plus h minus f of x over h. Now sometimes some books will use delta x instead of h, but it's the same thing. The rest of this is just notation, which you already know. Okay, now I am not going to have you do this. The book goes through many examples of actually using the limit definition to find derivatives. Of course, you know the derivative of x squared is 2x. And if I wanted the derivative at -2, you would take your 2x and replace the x by -2 and get a slope of -4. So I'm just going to show you this very quickly. If I did plug in h equals 0, I'd get, in this case, f of x minus f of x, or in any case, I'd get 0 over 0. In this particular case, my f of x is x squared. So my f of x is x squared. My f of x plus h is x plus h squared. Now what's going to happen if I expand this, the x squares will cancel, and if I factor out the h's, which is one of the processes we've learned, the h's will cancel, and then you'll replace h by 0, and surprise, surprise, you'll get 2x, which is the slope of the tangent line at that location. Now if it's at a particular number, instead of x and x, it'll be x1 and x1. Now, personally, if you were going to use a limit definition, you could do that, actually find f prime of a constant and replace the x1 by 3 and do it that way. I think it would be easier to use your limit definition on f of x squared. F of x equals x squared, use the limit definition to find f prime of x equals 2x, and then replace the x by 3. So here's another example of the same thing, only this time it's f of x equals x cubed, and there's the binomial expansion for that. etc. As I said, I'm not going to have you do this. I'm showing you this right now mainly because we're going to need it for the next section, 2.3E or F, I think. Okay, this is important and this is new, and this I will be testing you, and the AP always has a question on this. So it asks you in 2.1 on page 69 and 70, evaluate f of 2 and f of 2.1 and then use the results to approximate f prime of 2. Now they're very nice. They give you the function. So for example, for number 70, f of x is x cubed over 4. F of 2, of course, is 2. 2 cubed over 4 is 2. F of 2.1 is 2.1 cubed over 4, which if you used a calculator is 2.315. Now, what happens is we're going to approximate f of 2 basically because these 2 points are so close together. I have x equals 2 and the next point is 2.1. So if this is the point 2f of 2, very, very close to it is the point 2.1 comma f of 2.1. So what happens is if I find the slope between these 2 points, I'm going to have a very close approximation to the slope of the tangent line. Now, if these two x values were not close together, I would get a lousy approximation. So what we're going to do is we're going to approximate f of 2, and of course this is an approximation, and we're going to find the slope between find the slope of the secant line between those 2 points, which is f of 2.1 minus f of 2 over 2.1 minus 2. We found these two values up above, and we get an approximation of 3.15. Now, the AP is not going to be as kind. They're not going to give you the function. They're just going to give you a table of values, and they're going to ask you to, giving these values of x and these values, corresponding values of f of x, approximate f prime of 2. Okay, remember 5 is f of 2. We're looking for an approximation of f prime of 2. So you have a choice here. You can either use these 2 points or these 2 points. Or these 2 points. Any one of those will give you a good approximation. Of course, they will not give all 3 answers. They'll all be close to each other. But it is very easy to do. Either if you use these 2 points, it's f of 1.99 minus f of 2 over 1.99 minus 2. And of course f of 1.99 is given and f of 2 is given. Or you could use these 2 points here, the one to the left and the one to the right, or you could use these 2 points right here. So I will ask that on the next test. And that's the end of video 2.1a.